Now that I've built my COV rig, what's next? I realize that the COV is just some circles and a few lines, but these features actually represent so much more. I should point out that the only reference I've found to the COV framework at all comes from Bruce McAvoy's website. I'm incredibly thankful that he has shared his knowledge of perspective with the art community. Let me explain a bit more about the COV rig. To create a drawing in perspective, at minimum, I need to know what my primary object is and what the viewer's viewpoint is in relation to that object. I also need to understand how much of the scene can be taken in by the viewer. Humans, like myself, have an approximately 90-degree cone of view, including peripheral vision. My clearest area of vision, though, falls within a 60-degree cone of view. This means anything outside of a 60-degree cone of view begins to appear increasingly blurry. In the context of a perspective drawing, anything that falls outside the 60-degree cone of view appears increasingly distorted. The circle of view rig is a construction tool based on the cone of view. This outer circle represents the 90-degree cone of view. This illustration shows the basic circle of view rig. I'll be talking about each of its elements as they become relevant. Back in the landmarks illustration, I've labeled where many of these elements occur in physical space. The COV rig contains all of these same landmarks. If I return to the COV illustration, notice that I'm looking at my scene through the circle of view. In other words, my scene or drawing will be placed inside this construction tool. This illustration shows two additional circles of view, or COVs, with the format indicated as well. The format represents the paper size or screen size I've chosen for my drawing. Here the format size matches a 40-degree circle of view. The format can be any size in relation to the COV, but should not be larger than the 60-degree COV. Any portion of the drawing that falls outside of the 60-degree COV will appear distorted, which I'll demonstrate further in just a bit. In the previous lesson, I chose to create a COV based on this formula. 1.5 times the format size times 2 is equal to the 90-degree circle of view diameter. The first part of this equation determines my view distance, one of many factors working together that will allow me to measure depth accurately in my drawing. The view distance is represented by the horizontal radius on the COV rig. What do I mean by view distance? The view distance is measured between the viewer and the image plane. The 90-degree COV is also located on the image plane. If my image plane were to be further away, my view distance would be longer and my 90-degree COV would be larger accordingly. My drawing is part of the image plane as well. For this reason, the image plane is often called the picture plane. I think of the image plane as if it were a pane of glass the viewer sees a given scene through, like a sliding glass door or a picture window. The viewer is standing at some arbitrary distance in front of the glass and seeing a scene with objects at some arbitrary distance behind the glass. This world behind the glass is then able to project itself onto the glass. The three-dimensional world behind the glass now appears on a two-dimensional plane seen by the viewer in front of the glass. I am able to define points in space that create relationships between the viewer and objects within my drawing. Without getting into all of the math involved to explain exactly how perspective works, the general idea is perspective is based on a relationship between points I can define with a right triangle, which is a triangle that contains a 90-degree angle. There is a handy math property that says scaling a triangle proportionately preserves all of its internal angles, as I can demonstrate here. This means I can take real-world relationships and measurements and scale them down until they fit within my drawing format. I use the value of the longest edge of my format size, which was 12 inches, to fill in the equation. Remembering any part of my drawing falling outside of a COV gets increasingly distorted, it then makes sense to base the COV on the long edge of the format to minimize any possible distortion. So my view distance was calculated using 1.5 times 12, which equals 18 inches, and equal to the radius of my 90-degree COV. To get the full diameter of the COV, I only needed to multiply 18 times 2 to get 36 inches. In the lesson, I was able to take advantage of Affinity Designer's capability, allowing equations to be entered directly into the Transform Dialog's input fields. Now that I have a COV ready to go, I will build my drawing inside my format size. The structure itself contains defined points in space that help me create and measure objects in perspective. I think demonstrations are a lot more useful than extended explanations, though. In the next lesson, I'll be taking a closer look at the horizon line.